Hi, this video is dedicated to two of my recordings of the June 2015 leap second. The first part of the video airs my record of the Greenwich Time Signal, or the PIPS, a series of short tones broadcast by BBC radio stations. Then the shorter second portion presents a computer screen capture of two different time sources. At the time of the leap second, we were using British Summer Time, so the local time in the United Kingdom was an hour ahead of UTC. So first, to the Greenwich Time Signal. In this picture, you can see an HF radio set tuned to 198 kHz in the centre of the screen, and a handheld radio tuned to the same station broadcasting on 103.6 MHz towards the left of the screen for backup purposes. Above the radio is an LED connected to an MSF receiver. It's flashing in correspondence with the MSF carrier, although the signal has been inverted, so the LED goes on at the start of each second instead of following the carrier, which will go off at the start of each second. Have a look at my blog linked below for more information. The PIPS are a time signal derived from an atomic clock in the cellars of Broadcasting House in London. They are broadcast on radio stations such as Radio 4 to mark the start of most hours. The BBC compensates for the time delay in both the transmitting and receiving equipment so that they can be received to a specified accuracy on long-wave radio within 100 miles of the Droitwich AM transmitter. As the crow flies, my home location is just under 90 miles from the transmitter, so in this video you really will be hearing the leap second at the moment it actually occurred. Usually, there are 5 short tones, 1 per second, before the start of an hour, which is then marked by 1 long tone. Thus the PIPs start at 59 minutes and 55 seconds after the hour. This behaviour is illustrated by the top of the 2 waveforms pictured at the bottom of the screen. However, when a leap second occurs, there are 7 PIPs. They still start at 59 minutes and 55 seconds after the hour, and the hour is still marked by the long PIP, but an extra short PIP is inserted during the leap second. These rare 7 tones are illustrated by the lower waveform at the bottom of the screen. Now, as regular late-night Radio 4 listeners will be familiar, after the shipping forecast at 0048 local time, the end of the day's broadcasting is marked by the national anthem followed by the PIPs at 1 AM. This is where the following audio starts, which is taken from the 198 kHz AM signal coming from the HF radio. Listen for the 7 PIPs now. And there we have our leap second. The flashing LED that you just saw at the start of the minute is caused by a bit pattern in the MSF carrier that indicates that DUT is roughly equal to positive 300 milliseconds, corrected from the previous value of negative 700 milliseconds by the leap second, which was pushing UTC back by a second relative to UT1. Again, see my blog for more details and a proper MSF recording of the event. Here we have a browser window on the left showing www.time.gov. On the right, we have a script showing the Unix timestamp. Time.gov synchronises with NIST every 10 minutes. Usually, at the end of an hour, the seconds counter would roll over from 59 to 00. However, during the leap second, the seconds counter will read 60. Unix time increases by exactly 86,400 seconds each day, no matter how long the day really is. The POSIX standard specifies that the time number should increase continuously during the leap second and then jump back by 1 at the end of the leap second. Here, I'm just displaying the integer timestamp, so we'll have to see how it appears on screen. And again we have our leap second. That's all I've got in this video. Thank you very much for watching. Check out my blog, linked in the comments, for more recordings and analysis, including the MSF signal on its own and some NTP servers. And of course, feel free to post questions or suggestions in the comments below. Goodbye.